Alright, what's up guys? In this video we're going to pick up with some multivariable calculus, and we're going to be talking about the unit tangent vector. So we're asked to find the unit tangent vector for the following parameterized curve. So we're given r of t is equal to 5 cosine of t, 5 sine of t, comma, square root of 3 times t. So finding the unit tangent vector is very simple. Just have to kind of remember our formula for it. So remember that the unit tangent vector, which is denoted t of t, that's just going to be equal to the first derivative of r of t. So it will be r prime of t all divided by the norm, or the magnitude of the first derivative of r of t, or the first derivative of the parameterized curve. And that's the formula for it. So it's pretty straightforward. So we'll begin by taking the first derivative, and we'll get that out of the way, and then we'll tackle everything else. So remember how you do this. You just take the derivative of each component. So it'll be minus 5 sine t, or sine of t, excuse me, comma 5 cosine of t. And then this would just be the square root of 3. So that'll be our first derivative. Now let's find the magnitude, which is just the square root of the sum of the components squared. So we'll need to make some room here and plug everything in. So we'll have a negative 5 sine of t squared. We'll add that to 5 cosine of t squared plus the square root of 3 squared. And we just continue to simplify everything. So we know that this gives us 25 sine squared of t plus another 25 cosine squared of t. Anytime I square root, I just get what's under it. So then this just becomes 3. And then we simplify it a little bit. So we can factor out a 25. When factoring out a 25, we'll get 25 sine squared of t plus cosine squared of t. Now we know that from trigonometry that sine squared of theta plus cosine squared of theta is equal to 1. So sine squared of t plus cosine squared of t is also equal to 1. So this is really nothing more than the square root of 25 plus 3, which we know is the square root of 28. Now you can do some prime factorization on the square root of 28, and you can just write that as 2 times the square root of 7. And so, therefore, the magnitude of the first derivative of r of t is going to be equal to 2 times the square root of 7. Okay, so hopefully that makes sense so far. Now to finish it up, we're just going to kind of clean things up a little bit, and we'll have our unit tangent vector. So let's get another sheet here. So when we get another sheet here, and we'll have to do a little bit of simplifying as well. So we'll just take our first derivative, which was negative 5 sine of t, comma 5 cosine of t, and then comma square root of 3. And we need to divide that by 2 times the square root of 7. Now, you don't want to keep square roots in the denominator. It is very bad to leave square roots in the denominator, and some professors will kill you on points if you do that. So multiply both the numerator and denominator by the square root of 7, and what that's going to do is the square root of 7 times the square root of 7 is just 7, so that'll get the square root out of the denominator. And we can actually go ahead and write our final answer at that point as well. So kind of kill 2 birds with 1 stone. And like I said, it's a pretty straightforward process here. So we were looking for the unit tangent vector. That's what we're looking for. And we're going to write our answer down here. So t of t in this case, it's just going to be negative. I'm bringing negative to the side. It's going to be negative 5 times the square root of 7 all over 14, because 2 times 7 is 14. Multiplied by sine of t, comma, 5 times the square root of 7 all over 14. Multiplied by cosine of t. And then we'll have to do it. The square root of 3 times the square root of 7 is just going to be square root of 21. So this would be the square root of 21 all over 14. and that will be your unit tangent vector. And that's your answer. So as long as you know how to take derivatives, as long as you're cool working with, vectors and that sort of stuff, you won't learn this stuff till Calc 3 anyway, but once you get comfortable with all that stuff, finding the unit tangent vector isn't going to be very difficult at all. And once you start learning how to do unit tangent vector and, how to find, multivariable calculus gets really, really fun once you start trying to find the curvature. I just love Calc 3. Calc 3 was the funnest class that I took. So it gets really, really cool once you start learning some of this stuff. So so that's how you do it. So let me know if you got any questions about this, and I'll try to help you out as much as possible. So I'll see y'all next time.